Hey, what's up everybody? Welcome to the 25 concept summary videos of SAT Math, and today we are going to learn everything about parabolas, the concepts, every single concept that SAT Math can test you on the topic of parabolas, and then type of questions. Let's get started. Okay, so first of all, what is a parabola? What is a parabola? So you might have, so see guys, I'm not going to teach you every single concept in these videos because I'm assuming that if you're preparing for SAT Math, then you have already learned these concepts in your high school, in your grade 8, 9, 6, 7, 8, 9. So I'm not going to teach these concepts. So I'm going to assume that you know the basics of these concepts, and I'm just going to discuss the questions, the different types of questions and different types of concepts that are tested and how differently they are tested on SAT Math. So first of all, quickly, what are parabolas? Parabolas are these kind of shapes. You must know that this is a parabola. You must be knowing about the shape of a parabola. Yeah. So this is the parabola, and a parabola can be like this, it can be like this, it can be like this, and it can be like this. Okay. So this is the parabola. Now, first of all, equation of a parabola. Now see, every single thing in math has, every single figure in two-dimensional space has an equation. So a parabola also has an equation, and its equation is actually a quadratic equation. A quadratic equation. A quadratic equation is this: ax squared plus bx plus c equals to 0. So if we draw the graph of a quadratic equation, we get a parabola. Now the thing is that this is called the standard form. This is called the standard form of quadratic equation. Now just by looking at this equation, can you tell me what are the coordinates of the center of this parabola? Now see, this point that you see, this point is the center of the parabola. Let me just shift it. Yeah. So this point, it's called the center of the parabola. Now if I ask you what are the coordinates of the center of this parabola, and some equation of the parabola is given to you, can you find that out just by looking at the equation? No, we cannot tell the coordinates of the center of a parabola. This is also called the vertex. This is also called the vertex of the parabola. So if I ask you the center of this, the coordinates of this vertex, just by looking at the equation, we cannot tell that. In order to tell the coordinates of the vertex, we need to convert this quadratic equation from standard form to vertex form. From standard form to vertex form. And the vertex form is given by a times x minus h whole square plus k equals to 0. And here this h and k, h comma k, are the coordinates of the vertex. Coordinates of the vertex. So this vertex has coordinates h comma k. We'll see an example. So this is actually one of the characteristics of parabola, which is the third concept. So we have done equation of a parabola. Equation of a parabola is a quadratic. Then we have seen the graph of a parabola, and then next thing is characteristics of a parabola. So vertex is one of many characteristics of a parabola. Next we have axis of symmetry. The next characteristic is axis of symmetry. So axis of symmetry for this particular parabola is y-axis. Now what is axis of symmetry? Axis of symmetry is that line around which the parabola is symmetric. So this parabola is symmetric around this line, and the equation of this line is given by, so first of all, this is axis of symmetry. Let's write that. So this is axis of symmetry, and its equation is given by x equals minus b over 2a. This is the next characteristic. X is equal to negative b over 2a. This is axis of symmetry. Then we have something called maximum or minimum value that this function will take. So the maximum, in order to find out the maximum or minimum value, first of all, in this kind of parabola, this is called opening upward. So in this case, you'll get a minimum value. Okay, so this value, this particular value, this is gonna be the minimum value of the parabola. Now if you have to find out the minimum value, what you will do is we will find out the value of this equation at x equals negative b over 2a. So if you have a quadratic function fx equals ax square plus bx plus c, and you have to find out its minimum value, so in that case we are going to substitute x equals minus b over 2a. Minus b over 2a, and then whatever you will get, that will be your minimum value, minimum or maximum value, in case you have an upward opening parabola like this. Alright, so that's it. Now let's get started with the questions. These are the three characteristics of parabolas. Let's get started with the first question. So we have fx equals x squared plus 2x minus 2, which is obviously the function which represents a parabola, and we need to find out its y-intercept, axis of symmetry, vertex, and maximum or minimum value. So let's get started. So first off, we have the y-intercept. Now what actually is y-intercept? Y-intercept is that point at which the graph of the parabola is touching the y-axis. Wherever the graph is touching the y-axis, that point is called the y-intercept. So for example, if these are my axes and the parabola is like this, so it's touching the y-axis at this point, and at this point, since this point lies on the y-axis, then x coordinate is going to be 0, right? Because every point on the y-axis has its x coordinate as 0. So this point is of the form 0 comma y. So in order to find out the y-intercept of this parabola, what we need to do is we will put x is equal to 0 in this function, okay? Because at this point x coordinate is 0. So let's do this. So f of 0 is gonna be 0 square plus 2 times 0 minus 2. So this is 0 plus 0 minus 2. So the y-intercept is negative 2. So actually this parabola is 2 units below the origin. This point is going to be 0 comma negative 2. Okay, next we have axis of symmetry. Axis of symmetry. So equation of axis of symmetry is given by x equals negative b over 2a. What are the values of a, b, and c here? A is 1, a is 1, b is 2, and c is negative 2. So the equation x equals negative b over 2a is going to be negative 2 over 2 times a, which is 1. So this is nothing but negative 1. So the equation of axis of symmetry is x equals negative 1. Alright. Next we need to find out the coordinates of the vertex. So if you remember from the previous slide, the vertex is also the minimum or maximum value, and in order to find out the coordinates of the vertex, all you need to do now, see, this x equals 1 is the x coordinate of the vertex. Now we need to find out the y coordinate. So we will substitute x equals -1 in the function. So we have f of x equals -1 square plus 2 times -1 minus 2. So -1 square is 1, 2 times -1 is -2 minus 2. So 1 minus 4, which is -3. So coordinates of the vertex are -1 comma -3. Next we have maximum or minimum value, and the minimum value is nothing but, okay, we don't have to find out the minimum value, we just have to find out whether this parabola is going to have a maximum value or a minimum value. Now the thing is, if your parabola is upward opening, if your parabola is upward opening, then it will have a minimum value. And if your parabola is downward opening, then you will have a maximum value. But the problem here is that the graph of the parabola is not given, but only the equation of the parabola is given. So by looking at the equation, how can you tell that whether it is an upward opening or downward opening parabola? So an upward opening parabola has equation like this, and here your a is positive, okay, your a is positive, and in downward opening parabola your a will be negative. So in this case, value of a is 1, the coefficient of x square is positive. So this is the case of upward opening parabola. This is this case. So in this case we will have the minimum value, and that is actually nothing but the y coordinate of the vertex, -3. -3 will be the minimum value. Okay, let's take the next question. So this question was based on the first concept, this concept, characteristics of a parabola, finding out the characteristics. Next we'll do a question on finding out the x-intercepts. Now here a quadratic equation is given to us, and we are asked that for what value of c will the function above have one solution. Okay, one solution. So this is actually your very straight away question of quadratics. So if you know, a quadratic equation can have either, it can have either two solutions, or it can have one solution, or it can have no real solutions. So two real solutions, one real solution, which actually it has, in this case as well, it has two real solutions, but those two solutions are repeated, so we call it one real solution. And the third case is no real solutions. So in this case, it's given that this equation has just one solution, so they're talking about second case. Now there is something called as discriminant. It's given by b square minus 4ac. So all you need to do is find out this quantity. You need to find out the value of b square minus 4ac, and if this equation has two real solutions, then this quantity will be positive. And if this equation if a quadratic equation has one real solution, then this quantity will be equal to 0. And if it has no real solutions, then this quantity will be less than 0. So in this case, we are talking about one solution. So this quantity d, b square minus 4ac, should be equal to 0. So first let's write down the values of a, b and c. So here my A is equal to -2, B is equal to 6, and C is just C. So now let's find out what is B square minus 4AC. B square minus 4AC. B is 6, so 6 square minus 4 times A, which is -2. C is just C. This has to be equal to 0. So 6 square is 36. This is going to be -4 times -2 is going to be +8. So plus 8 times C is equal to 0. 8C is equal to -36. Divide the equation by 8. They both get cancelled by 4. So 4 times -9. 4 times 2. So -9/2. So for C equals -9/2, we will have one solution for this quadratic equation. Now this was a very straightforward way of asking this question, but other way in which this question can be asked is, for what values of C this function will intersect the x-axis at just one point. You see, solution is nothing but the point at which the graph will intersect the x-axis. So my parabola can intersect the x-axis in three different ways. It can intersect the x-axis like this. It can just touch the x-axis like this, or it will not touch the x-axis at all. So when you have the first case, when the graph is touching the x-axis, this is the case where you are getting 2 points of intersections, which are your solutions as well. So if they ask in a question that for what values of C this graph will touch the x-axis at 2 points, or this graph will have, you know, 2 intercepts with the x-axis. So in that case, they are talking about finding out 2 real solutions. In this case, you have just one real solution. So in this case, the graph is touching the x-axis at just 1 point. And in this case, this is a case of no real solution. So the graph is not touching the x-axis at all. Okay, so that's another way the question can be asked. And actually, most likely they are going to ask the question in this way. Alright, let's see the next question. Next we have the intersection of parabola and a line. So this question says that line y equals a and parabola y equals -2x squared plus 3x intersect at exactly 1 point. And if a is positive, if a is greater than 0, then find the value of a. So this is the case of intersection of parabola and a line. And again, you can have 3 possibilities with a parabola and a line. So if this is a parabola, a line can intersect like this. Like this. You have 2 points of intersection. Then similarly, a line can touch like this, and a line can be like this. So this is the second case in which the line is intersecting the parabola at exactly 1 point. But in this case, the equation of the line is given, which is y equals a, and we have the equation of the parabola. So what you need to do is, you need to substitute the value of y from this equation to this equation. So we know that y is equal to a. So in place of this y, I'm going to put a. So we get a equals -2x squared plus 3x. Okay, let's do some manipulation. So -2x squared plus 3x minus a is equal to 0. And now what you need to do is, since this is a case of one solution, so again what you will do is you will set the discriminant equal to 0. So let's find out the discriminant. So value of b is 3, a is -2, and here c is -a. So b squared, that means 3 squared minus 4 times a is -2, and C is negative A. So 3 square is 9. Now negative 4 times negative 2 times negative 8 is going to be negative 4 times negative 2 is positive 8, and 8 times negative A is negative 8A. So this is going to be equal to 0. So 9 is equal to 8A. So that means A is equal to 9 over 8. So for A is equal to 9 over 8, this line and this parabola will intersect at exactly one point. So that's it. That covers every single concept about parabolas. But there can be, there can be different cases of parabolas. Like they can give you a parabola which is upward opening or downward opening, or like this or like this. So it all comes down to how many different types of questions you are practicing, how many different scenarios you're practicing, how many practice papers you're doing. So yes, the more you practice, the better your score will be. That's it for this video. I'll see you in the next video. Bye bye, and all the best for your SAT math.